Hello, everybody. It is officially past 7 o'clock, so that means we got to get started. Hello from over here. We have a short audio cord today, so I'm just like in the corner by myself. All right. Hello. What is up, my dudes? Hello. Welcome. Any first-timers out here tonight? Kyle. We got a couple out here tonight. All right. Welcome. Welcome. Everybody else has been here, done that. Before we get started, I want to give a very loud and warm shout out to our most recently minted Ph.Ds from the UTSA Physics Department. We have Dr. Caleb Gimar. Woo! We'll be hearing from Dr. Gimar in about half an hour. And then as of 5 hours ago, Dr. Michael Preston. Woo! Somebody get this man a drink. I would say get Caleb a drink, but he doesn't drink, so. Now.
Sometimes I do. It depends if I'm driving.
Yeah, occasionally.
And yes. And if we encourage him enough, Michael Preston will give a talk here at some point.
Yeah.
So, yes, we'll hear from him.
All right. Everyone who's been out here before, we all know the deal, but for the first timers out here tonight, Michael. Oh, wait, I got to introduce everybody. My name's Aaron. Michael's over here. Erica's running the show online. Adam and Brian are doing something at UTSA with small businesses and Linux, and so they're not available, but Adam was here earlier helping us out. And then Jasmine is doing homework tonight, and Thomas is online, I think, should be watching, and then Tracy the OG is at home tonight.
She's dealing with the kiddos.
And Caleb does partly of the Astro News, the slides, does the star stuff. So, yeah. So
Yes.
still part of the hosts. So that's who we are. And Michael, would you like to explain to the crowd what Astronomy on Tap is?
Yes, and before I do, peep our new logos. They're officially on the slide deck, and soon they will be in your homes.
Officially incorporated.
When you buy our future merch. Please. What is Astronomy on Tap? Well, it's a worldwide phenomena with locations all across the globe. Our very own location is now going on 8 years, incredibly enough.
Almost 9 now.
Yeah, that's true. In 2026, I forget when the first one was. We'll have to get back on that. But this is the 60th event for us, so that's exciting. I remember our big 50th shindig, so time passes quickly. But what stands us out from the rest? Well, I'd like to think we're interesting. We've got two very interesting talks coming to you tonight from our great speakers. And part of it is interactive, because you'll be able to text our phone line here and ask questions of our speakers and learn a little something. And then fun. At the end, we're going to do our usual trivia. And tonight we've got some interesting posters for prizes, including this. Look at that. Lithograph. Yeah. And this is contemporary because poor Pluto isn't there. And yes, and later on in the slide deck, we'll have information for if y'all aren't already part of our email list or following our socials, please do, so that we can keep you around. And this week's photo submitted to Sam. Once again, Lee, because Lee is the only person that takes good. No, we love Lee's photos, great photos. And of course, what better place to take a photo than Big Bend? I mean, the skies there are gorgeous, and the Milky Way at Big Bend is just something you have to go see for yourself. This is really cool with the rocks in the background, too, and a nice framing there.
When they're that big, they're mountains.
What?
When they're that big, they're mountains.
Oh, yes, they're almost. All right. Tonight's agenda is our first talk will be by Dr. Lindsay Fuller from UTSA, Canary Islanders, a random walk from Spanish Colonial Texas to Modern Astronomy in SATX. And then yours truly will give tonight's astronomy news. And then we'll move to Dr. Caleb Gimar's talk on strange stars, strange particles, strange planets, my journey to a physics Ph.D. And then we'll round it off with a special trivia tonight. Sam has gone above and beyond because we all complained to him. So thank you for complaining. It worked.
He went beyond.
Beyond.
Yeah.
It's going to be Who Wants to Be a Millionaire style tonight. So the questions will get progressively harder. And the minute you get one wrong, then we're going to shoot you out of a cannon into the river. But yes, so Aaron will introduce Dr. Fuller.
All right. Dr. Fuller is currently faculty at the University of Texas at San Antonio, where she received her Ph.D. in physics in 2017. Her research focus is in observational data analysis of the environment surrounding supermassive black holes in distant galaxies using infrared telescopes, primarily the now decommissioned airborne platform SOFIA, RIP. She double majored in physics and astronomy at UT Austin in 2012, where she primarily studied laser science. Before entering academia, Dr. Fuller served as aircrew in the U.S. Air Force. And then for the uninitiated, we have a drinking word, pretty straightforward. You hear the word, you drink. Lindsay, what is your drinking word?
My drinking word is Spain.
Woo!
All right. Okay. So, in my recent, in the recent past, I say recent, past 10 years or so, the Canary Islands, the subject of the Canary Islands keeps coming up in my life, and basically, it's like, so I've actually put a PDF on everybody's table, and so this kind of explains what I'm going to talk about. But where I want to start is actually the year-ish, something like 1994. I don't know. I was born in 82, and I was about this age. So whatever year that was, it might have been 92. This is me and my grandma, and we are in Lake Charles, Louisiana, and this is, we were actually in the Mardi Gras parade because, like, Mardi Gras on Lake Charles, man. Anyway, so it was around this time that I asked my grandma, I said, hey, are we French? Because my last name is Fuller, which is obviously not French, but we're, deep in French culture and stuff, and so I kind of assumed that we were French, and I said, are we French? And she said, no, my maiden name is Corbello, and Corbello is a Spanish name. My ancestors came to the U.S. from the Canary Islands. They came over and they settled in San Antonio, and then somewhere along the line, my ancestor moved to Lake Charles because Lake Charles is in between San Antonio and New Orleans. And they set up some kind of, hitching post, I don't know what you called it back then, for travelers that are going between San Antonio and New Orleans. And I was like, okay, that's weird, whatever. Because I had only ever lived in, I had never, thought about Texas or anything like that. So I was just like, all right, cool. My grandmother's family is from the Canary Islands, fine. So then fast forward to 2013, I moved to San Antonio for grad school. And so this was just, it wasn't because I had a tie here, it was just because this is where I chose to go. And it's close enough to my family that I can drive in a day and far enough that they don't hang out with me. I hope they don't watch this. And so I had my advisor at the time was Dr. Chris Packham, and he had lived in the Canaries because there's a bunch of telescopes in the Canary Islands. And so he had been in he had lived in the island of La Palma, and we had a postdoc at the time named Enrique, and he was from the island of Tenerife in the Canaries. And so I remember telling them, oh yeah, one of my ancestors from over there. And I know, and I had gone down to the Founders Monument that's right in front of the Bexar County Courthouse, and you can find my ancestor's name on the plaque down by the Founders Monument, Juan Corbello. The spelling has changed because when they moved to Louisiana, the French couldn't help themselves. They were like, I don't know what this is. We have to change it. And so this is the original spelling of the Corbello name, is the one that you see here on the plaque. And so let's go back a little bit and say and ask ourselves, why would anybody from the Canary Islands come and settle Texas? Let's go through the history lesson. So back in the day, King Philip was like, all right, I need more people to go live in New Spain because I need for more people to go live in the province of Texas because basically he was afraid of the French, like this is French territory over here. And so he was afraid that the French were going to come and like try to steal his land. As a side note, there was a French explorer that accidentally shipwrecked in Matagorda Bay, and that shipwreck is in the Bob Bullock Museum in Austin if you ever go. Anyway, so I mean, it was kind of warranted for the King of Spain to be, like a little bit upset, like, these French are going to come, like, take all my territory. And so he wanted a bunch of people from Spain to go and actually populate Texas. I promise it gets it. It's not like that every slide. I need people to go to Texas because we need people there that aren't just military or clergy, because military and clergy don't really settle down and have families and stuff like that. So we need to grow the population. And so he said, who wants to go to Texas? And all the mainland, all the people in mainland Spain were like, But then there were a bunch of people in the Canary Islands that were like, well, my island is a volcano, and we don't get a whole lot of rain, and there's not a whole lot of room for agriculture, so you know what, I'll take a shot, and I'm going to go to Texas. And so, the next question is, where exactly are the Canary Islands, and what do they look like? So the Canaries are actually here off the coast of Africa. This is right off the coast of the Saharan Desert. And so these are all volcanic islands, and these two here, kind of low elevation, these two here, or these four here, high elevation. And so basically what happens is you have this dry air that comes off of the coast of Africa, and it kind of blows a lot of the moisture away from the islands, so that the only moisture that you get is from these clouds. And so if you're a low elevation island, volcanic island, that doesn't have any, rivers or water or lakes or anything, there's no way for you to have any kind of real agriculture here. And so my ancestors came from this island here, and most of the people that moved here came from this island. There are a few from the other islands. But basically, another kind of cool thing about the Canary Islands is that they're right at the head of these trade winds. And so, like, because you're in this, like, right sweet spot in the world, basically, like, if you sail from the Canary Islands, you go straight across the Atlantic. And this is also the path of hurricanes. So this is, like, a very, like, wind-driven area. So you have wind coming off of the Sahara Desert, and it can basically blows all the moisture away from the Canary Islands, but it also blows ships across here. And fun fact, Christopher Columbus came from mainland Spain, went down to the Canaries, filled his ships with whatever you need to fill them with, and then set sail for what he thought was India and ended up somewhere over here. But that's kind of why Christopher Columbus ended up in the Caribbean, was because of these trade winds. That's where they take you. So in the Canaries, you have these two kind of like low elevation islands here, and then a couple of high elevation islands here. And so what you can do is if you put a telescope at a high enough elevation, you get away from all these clouds. And so on the island of La Palma, there's an observatory right here. And then on the island of Tenerife, there's an observatory here. And so, yeah, high altitude, dry Saharan air, and you're close to the equator, so you can see a lot of the sky. So in 2013, my advisor let me go on a work trip to the island of La Palma. This is the picture that I had originally sent. Now, granted, it's from 12 years ago, but I still look the same. So this is the island of La Palma, and La Palma hosts the largest optical telescope in the world. There are some radio telescopes that have different, they just work differently, and so they're technically larger. But as far as optical telescopes go, this one is the largest in the world, and it's called the Gran Telescopio Canarias. And I was fortunate enough to be able to use some data from the Canaries in my very first paper that I ever published, so that's pretty cool. And if you're looking at, if you're kind of looking downhill at the telescope here, then straight behind you is this caldera, because this is all, these islands are all volcanic. And so this is a picture of me by this literally like a big volcano hole. And up here you can kind of see how you're above the clouds there. There's that cloud layer. So after, back in 2013, after I went to La Palma, we took a quick trip to Tenerife for a couple of days. And I show this to show that, so there's the other observatory in Tenerife, and you're right by the El Teide volcano. And you can see that, like, this is literally just like this. It looks like the moon. It looks like a literal moonscape on these islands, except for when you're inside of that cloud layer. It's like a jungle. So yeah. So this is what it's like when you're even with the clouds. Yeah. So even down by the ocean, you can see like there's ocean water and then just volcanic rock. So, a few years go by, and Chris Packham and I got involved with the Whitty Museum. And so what we did with the Whitty Museum was we kind of came up with this program where we would talk about the history of San Antonio and how these Canary Islanders came over from the Canary Islands, from Spain, and how the Canary Islanders came over and settled San Antonio. And then we would dial in with the telescopes over at La Palma. And so we would talk about not only the history of San Antonio, but we would also talk about like the modern astronomy that's going on in La Palma today. And so that's what I put on everybody's table, is the flyer that we made. I thought it was cute. So I don't know how else to fill in the space there. Yada, yada, yada. In February of 2020, I attended a meeting of, there's an organization here in San Antonio called the Canary Islander Descendants Association. And in February, I attended one of the meetings because I was like, I think I'm one of you guys. And then like COVID happened. And so nothing came of that until after COVID. We finally looked at all of my documents, and they said like, yep, you're legit. You are an ancestor or a descendant of the original Canary Islanders that came over from Spain. And so I became a member in August of 2023. And then in January of this year, I actually became a board member, and that has taken up a lot of my life. But honestly, it's been so rewarding because like I found out so many things about myself and the history of the town, things that I never knew, because a lot of times like the history of San Antonio kind of starts at the Alamo, but the Alamo was there for over 100 years before there was ever a battle there. And so I wish I could get into what happened during those 100 years, but I can't. There's not enough time at all. Anyway, so one cool thing that happened, in March, that's not the laser. In March of this year, San Antonio signed a sister city agreement with the island of Lanzarote, which is where my ancestor and most of the Canary Islander ancestors are from. And then in May, I was able to go for work. Yay! And then shout out, because I actually stopped in Spain. I stopped on the mainland and hung out with Aaron and Tracy for a few days because they happened to already be in Spain at the time. And so I stopped, caught a bus, and was like, hey guys, and we all hung out for a little bit. I came back and then caught a plane down to Tenerife. And so I just wanted to show a few pictures of my time in Tenerife. We were there at the facility is called the Instituto Astrofísica de Canarias, the IAC. I say it very well, I know. Anyway, so I wore my UTSA shirt here, and I love this photo because not only can you see the telescopes, but you can also see Gran Canaria in the background there. And here's the UTSA contingent that went. There's Dr. Packham, Lulu Zhang, John Schneider, and then we have the volcano El Teide in the background. And so my job there was to promote an exchange program between UTSA Physics and Astronomy and the IAC so that we can hopefully send some of our students directly to the IAC so that they can do some like research and observing stuff like that. So after this, then I was like, took a vacation, and I was like, I want to go to this island where my ancestor is from. And so I went. And the cool thing, and the primary reason that I wanted to go is because I had heard about this like winemaking process that happens on the island of Lanzarote. And so if I could, there we go. And so I go there, and the entire island is volcano. So, by the way, side note, after the Canary Islanders moved over in 1730, a few months later, there was 6 years of volcanic activity on this island. so like, I guess they kind of, they kind of did it right. Anyway, so over where that volcano was going off for 6 years, they have this crazy, I don't know anything about agriculture, but they have this like crazy type of soil, and it's all volcanic. But what they do is they dig out these pits. And so what the pits do is not only does it protect the vine from those trade winds, from those Saharan winds, it also collects the dew because there's no rain and all you have are those clouds. It collects the dew from those clouds, and that's how you water your vines. And it's super labor intensive, apparently, from what I've heard. It's one of the most, if not the most labor intensive way to make wine in the world. And in my opinion, it's the absolute most unique wine region in the whole world. And so I went wine tasting there. And I had met this guy, and I was like, hey, do you want to go wine tasting with me on a volcanic island? And he was like, sure. And so he went with me. But yeah, you can just see like these landscapes. I mean, it's as far as the eye can see, these pits, and there's just these vines and these pits, and it was one of the most amazing things that I've ever seen. And then, we have a picture like by the beach, and you can just still see how it looks like this kind of like moonscape where it's just nothing but volcanic rock. Even though you're right by the beach, there's no plants. And so even when I was there, I was like, no wonder these people were like, when the King of Spain said, hey, we need people to go, populate Texas. These people were like, I'll go. Let me go. By the way, so what I wanted to say is that I know that there are talks, and I can't make any promises because I'm just me and I'm not a person who can have any effect on this, but apparently there are talks in place to bring this Canarian wine to Central Market. Ooh, yeah. So if this happens, which whoever they is, if it happens, they want it to happen, and they are going to try to make it happen. I'll let you guys know. Anyway, so let's go back to me trying to kind of figure out the history of my family because I find it interesting. So I ran across this website, and it had all these maps. And I was trying to find specifically like where my family's property was and stuff like that. And so this guy, his name's Clint McKenzie, he's an archaeologist at UTSA, he had put together all these maps. And so I was looking through this website, and I found kind of this one map. Okay, we know that this is where the current Riverwalk is right here, and this is where City Hall is, this is the Alamo. And it says that this is the first site of the Presidio of Bear. Now, does anybody find this a little bit familiar, like this site right by San Pedro Springs? Scobie Planetarium. Exactly. Yes. So right where they very first, I mean, it might be like a little bit right here, but right where they very first wanted to put the first Presidio in San Antonio was right by the Scobie Planetarium. And I was like, well, that's kind of cool. But for some reason, it didn't work out. I think like it was hard to get the water up. I don't know. But they eventually moved it down to where Main Plaza is now. And so then I wanted to look at, like, where's my family's land? Where's my family's property, right? And so I found out, so this is Main Plaza here. There's the Riverwalk. And I found out that I have my ancestors, the father and the son, have houses right here. So everything in yellow is basically, it's called the Presidiales. It's everybody that worked in the Presidio, all of the military people. But all of the civilians, all of the Canary Islanders had all what you see in red. And so I looked and I was like, whoa, look, my ancestor had a block right here on Commerce, and then a block right here. This is where the present day courthouse is, and that's where my ancestor's house is. I would absolutely love to tell you about this house, but I don't have the time. Anyway, so it actually got blown away by, or it got washed out by a flood. Anyway, so then I'm looking down and I'm like, okay, so which one of these plots was my ancestor? And I look and I see, okay, it's this plot here. Well, what's there now? What's on this plot? And I look and I'm like, okay, well I recognize Gunther Street. I recognize this three-way divide right here. Ceballos, okay. And I'm like, wait a second. I know this three-way stop. I've parked on Gunther Street. This is exactly where my ancestors' plot of land was, from here to San Pedro Springs. And so you're all on my land. All right. And now it's time for questions.
Thank you, Lindsay. That was fun. Reminder: text the number you see on the screen for any questions you may have. A hot topic of this talk was the volcano.
Yeah.
Is it active? Do they worry about it with the telescope?
So La Palma, there was a volcano that happened in La Palma like 4 years ago. So yes, the caldera where I was standing was is inactive, but there is still volcanic activity on all of the islands. Specifically 4 years ago on La Palma, but like maybe every 100 years something erupts there. I think the one previous was on Tenerife maybe 150 years ago, but then the one on Lanzarote, that was in 1730, so that was 300 years ago.
I guess maybe the seismic activity is more of an impact than the volcano?
Yeah. So, I mean, they're going to erupt a little bit here and there. I mean, just like Hawaii. Hawaii just erupted. I mean, so it's the same concept of Hawaii. You have this archipelago that kind of keeps coming up because there's volcanic activity there, and then the earth shifts, and then there's another island that forms because of that volcanic activity. But it's constant. Yeah, it's still active.
So you said you flew into Tenerife.
Yes.
You have to like go to Spain.
Yes.
And then fly some small airliner to.
Yeah, pretty much. I think you can also fly in from like London and Brussels, Madrid, I think Morocco. But yeah, and there's a way that you can get there by ship, and I looked it up, but it's like a 20-hour boat ride from mainland Spain.
Do you know if the JWST took any knowledge from the GTC? They had like the same kind of mirror arrangement.
Right, they do. Yeah, they all have the same hexagonal thing, but JWST is 6 meters.
Yeah.
The GTC is 10.4. But then again, the JWST is outside of the atmosphere. But yeah, they have that same hexagonal shape on the mirror. But I mean, I don't know that there's any kind of other specific thing that comes directly from the GTC that translate to the JWST.
Yeah. What's involved in being in the CETA board?
They make me have meetings. I say that. We have meetings sometimes like on Mondays, like maybe every second or third Monday or something like that. But then a lot of time, so that's, stuff that's kind of like after work hours. But then a lot of times we get these really cool opportunities And we have, so the kind of organizational things that we have to do are Zoom meetings, and then we have in-person meetings once a month, and those are kind of the procedural things that I have to be a part of. And I had to like pass these bylaws the other day. We had a 3-hour Zoom meeting, but it gives me an opportunity to join these other cool things. So for example, I got to go to the Alamo back in September, and there was this big event, and they had all of the Canary Islanders coming in, and they had their wine, and they had their salt and goat cheese and stuff like that. And so we got special access to this party at the Alamo, and like the mayor was there, and the president of Lanzarote was there. And so that was one of the cool things that I was able to do because I'm on the board. But then also this Saturday we have an event, and because I'm on the board, they've asked us to participate at the San Antonio Mission Indians Descendants. So we'll be at, I think it's the Missions Library on Saturday. So on one hand, it's worky, but also kind of fun. Oh, and I was at the Alamo a couple of weekends ago, and I dressed up like a traditional Canary Islander at the Alamo on Tejano Day, but it's kind of weird because I'm like, my last name is Fuller, and I'm like, I am representing the Tejanos. So those are the kind of things that we do, the procedural things, and then kind of the fun after-hours stuff.
What's the astronomer residency like at the GTC, since it's on an island, kind of removed?
Yeah. So when we went up there, we actually got a taxi from the airport to the astronomer's lodge up there. So the drive, if you get queasy, be prepared, because it's the Canary Islands, man. This is not, there are no guardrails or anything like that. So I mean, you're like doing this all the way up there. And then, but once you get there, their astronomer's lodge is actually really good. It's really big.
I hope so.
Yeah. And so if you've ever been to the McDonald astronomer's lodge, it's very great and pretty and everything. But because this is a little bit more remote and it's on an island, it's kind of bigger and has like a lot more stuff. And their kitchen has a lot more items and stuff like that. But it's the same concept that, like, daytime is quiet hours, or 24 hours is quiet hours. And everything's dark during the day, and you have to draw the shades and all that. But I would say, of the 2 astronomers' lodges that I've ever been in I really love the McDonald Observatory, but they have more amenities around there, so the lodge doesn't have to have the amenities. But in La Palma, their astronomers' lodge is like on point, man. But then you have so many telescopes and so many people coming from all around the world that were staying there, and we were talking to all these different astronomers, from like Sweden, and some from Spain, and some from Switzerland or wherever. And so there were just like there were just more amenities there.
Yeah, I hope so. Being an island. And then finally, can you taste the terroir in the wine?
Yes, you absolutely can. And so, so one of the things that you'll taste in the wine, and I wish I had like a sample of wine that I could give all of you, but I have like 1 bottle at home, and that would suck for you to have like a sip, like a drop of wine for everybody. But there's a lot of minerality in that wine. So basically, like, you're an island with salt water, and you're in this volcanic terroir, and it has an absolutely, and the grape is called Malvasia volcanica, and so it absolutely has this very minerally taste. It tastes like rocks and salt, not volcano, not ash or anything like that, but it tastes like you're licking a rock, and grapes at the same time.
In a good way.
Yeah, in a really good way.
That's pretty interesting. Let's thank our speaker once again.
Thank you.
There were a couple more questions.
What was this, Lindsay? Lindsay,
Page
there
and
was
Dr.
a
Fuller.
slide.
That was going to be my second slide.
Oh.
Because this is in a book that I know, and it's like the timeline. And I was like, this reminds me of this
All right. Well, there you go. It was a timeline setting the stage slide. So we've set the stage post stage. It's okay. We're going to do our 10-minute break. So that means we'll go until 40, I can read or watch, 47. Reminder, if you take any cool photos, send your pictures to Samuel Hart Helio at gmail.com. And, we want everybody, not just Lee, but we love Lee's photos. 10 minutes. Okay, sorry. Okay. Okay, much better. Sorry about that. I am sometimes too loud. Scratch that, I am all the time too loud. Welcome back to our AOT. We will now continue with our tonight's news segment, which will be done by yours truly, because Jasmine is being a studious student tonight and doing homework. So we applaud her for that. Tonight's title, At Least We're Still Open. And our headlines are, what is the true nature of Comet 3I Atlas? More rockets? Star Eaters? Well, what do we got? We'll start off with our beautiful November sky. Saturn is almost directly overhead this month. Venus in the morning sky towards the east, and then the comet Lemon may still be visible mid-month at sunset, low in the west. Look online for more info. And then 3I Atlas may also be visible low in the sky. You need a dark sky, and you need a telescope, so you can't just large telescope. So I don't know if the telescope people are going to be doing stuff, but poke them, go find them and poke them. Andromeda Galaxy and Perseus double cluster, great deep sky sights to see in the month of November. And you can see, because we're going from summer to winter, so bye-bye to Scorpio, which is one of my favorite constellations. Always sad to see it go, but my second favorite's coming up, Orion. You'll see that rising in the sky as we go through November. And on a nice night, you'll get a beautiful view of Orion's nebula in the sword of Orion. And yes, so there's, once again, refreshing. There's Saturn, there's Jupiter, there's the North Star, and look, there's the little twins of Gemini. Woo! Yes, November. All right. So an update on 3I Atlas. It just passed perihelion, which is the closest distance it'll get to the sun, and it occurred on October 30th, and it came just inside of 1.4 AU. So it never is going to be within Earth's orbit, but it's still pretty darn close for it. So naturally, that makes it very active. This is the most active it's going to be with the sun, photons, and solar wind bombarding it. So this is a great time to study it. What we found so far is lots of water and carbon dioxide, which is expected for a comet. But I guess the unique thing is they keep thinking it's changing color. There's still more data analysis to be done to confirm these color changes, but color is basically a fingerprint. Color tells you what gas you're looking at, and you would expect an interstellar object to not have the same composition as our solar system. You would expect it to be, zany in that way. And so, we look forward to all of these future, current and future observations to learn more about it. And then speaking of that, look how many observatories, spacecraft, you name it, have looked at it already or will look at it. This list, and this isn't even an exhaustive list, but you see here just so many things. We're so lucky that we were able to catch this object early so that we could plan to observe it with all of these things. So we're going to learn a whole lot about it and a whole lot about interstellar space, because there's no other way to study it unless we get these serendipitous objects. So this image here is ExoMars, which is an ESA mission. GIF of, you see it passing by. It's Trace Gas Orbiter. So this was one of the more recent observations since our previous AOT. And then I've also bolded Europa Clipper and the Jupiter Icy Moons Explorer JUICE, because we're very, very excited here in San Antonio. Our UV instruments that we've spoken about ad nauseum to you are going to have an opportunity to see this comet tonight, literally tonight going into the morning. So there's the comet going by. So that was that perihelion I was talking about. So probably right now it's about here. And then Juice is right about here. And then Clipper's right about here. So this is pretty much the closest they're both going to get. And they're going to be co-pointed at the comet. So Juice from the inside of the solar system looking out, Clipper outside looking in with the UV spectrograph. So like I said, the comet's very active right now. So if what they're saying is true, that a lot of its mass has been lost, then you're going to see this huge coma around it, and you're going to get a lot of great data. So hopefully everything works out. You know, I can't guarantee anything, but we're going to try, and that's the important part. And that's the whole point of these space missions, is to do this kind of science. So we're really happy about it. And, you know, here's a great example of what Europa Clipper UVS would see. You know, 3I Atlas is just going to be a little dot, but we're just going to kind of scan across it to look for those gases around it. And like I said, hopefully we see some beautiful spectra. And maybe next month or the coming months, we can report on it. There's always constraints with spacecraft returning data back to Earth. Juice, like I said, it's inside. So right now, the antenna's pointed at the sun to keep the spacecraft cool. So that means you can't talk to Earth very much, because you can't point the antenna at Earth. So Juice will take a little while. But Europa Clipper, we might be able to see that data sooner than later. So hopefully, in a few AOTs, we'll be able to report on this. So we'll hold your breath. But not really. A new foe has appeared, because the Escapade mission to Mars will be launching on the New Glenn rocket. So now we have a new rocket that can launch missions. So that's exciting. We want more missions, so we need more rockets. So keep them coming. So this mission is called the Escape and Plasma Acceleration and Dynamics Explorers, plural, because it is two identical spacecraft that are in fact going to Mars, and they're going to study the solar wind interaction with the Mars magnetospheric environment, or magnetic environment. Mars does not produce its own magnetosphere like Earth does. It's induced by the solar wind. So these spacecraft will investigate how that actually works. And the launch is set for no earlier than this Sunday at 2:45 p.m. Eastern Standard Time. So that's Kennedy Space Center local time. So be on the lookout for that. It'd be New Glenn's second launch ever, and it would be its first ever launch of a official payload. So this is really exciting for NASA science. Another interesting thing, a black hole has consumed a star. So, you know, we always talk about, people always say, oh, black holes, they just suck everything in. That's not true. That's false. But they can disrupt. And that's exactly what's happening here. The star got too close, and it got ripped apart. And that first moment, as it was getting ripped apart, it brightened the emissions around the black hole by a magnitude of 40, which is just outrageous. This black hole happens to be at the center of AGN, or an active galactic nuclei. So these are galaxies that have supermassive black holes at their center in a very compact environment. So this is dynamic and violent, very violent. So that's why this is possible in this type of environment. And the time scale of this chart is from 2018 to now. So this is happening over such a large time scale that the brightening is coming down slowly. So they've been monitoring this for years. And there's a few other hypotheses, but they're pretty statistically significant, sure that this is what they saw, that they saw a star being disrupted. So that'd be pretty cool. And you can look this up. This is a publication that just came out in Nature Astronomy. So go ahead and look for that. As always, our fun pictures. We have the Hubble picture of the week provided by the European Space Agency of the galaxy NGC 4102, which is also an AGN. The Red Spider Nebula, or NGC 6537, from the JWST picture of the month, also by the European Space Agency, because they're not closed. Unfortunately, I don't have an astronomy picture of the day from NASA for you because, yeah. Wait, where's that last slide? I put another. Oh, well. Yeah. UTSA does the first Friday, and it's the second. Is it still the second Friday?
Yeah, no, it's this Friday coming up.
No, first Friday. And that's it?
That's it. Yeah,
Oh.
combine the two events together.
So Friday Night Celestial Lights is now the first Friday. You heard it here first, folks. Probably not, but, you know.
And South Yano's going to be on the 15th.
South Yano on the 15th?
15th, SAAA, they're still doing their every Wednesday at Raymond
Right.
Park. And then on November the 22nd, I think they have an event at Eisenhower Park starting at 6 o'clock p.m. And then, of course, Scobie Planetarium has their planetarium shows on every Friday night this month, except for Thanksgiving.
Right. Yes, so a quick recap. SAA does every Wednesday at Raymond Memphis. On Saturday the 22nd, they'll be at Eisenhower Park. And then you have the Scobie every Friday planetarium show, with the exception of Black Friday. When in doubt, look up the websites for all of these things. And like I said, or no, I didn't say this, but you know, when the weather gets good at this time of year, the sky gets better. So, and also it's darker for longer now because daylight savings has gone bye-bye. All right. Now we'll move on to our second and final speaker of the night, which will be introduced by Sam.
All right. I don't need Caleb to give me a bio because he's told me his life story a million times. This is a photo of Caleb when he was 21. So if you're like, who's that hot guy? He's right here. All right. Actually, Caleb, like a real narcissist, is just going to tell us about his whole life tonight, so you guys can hear this. So the story is the bio, really. So the things that you don't know, he went to Hutchinson High School in Hutchinson, Kansas. And then, wait, okay, do you talk about Goddard? Yeah. Okay, then that's really everything you need to know. He's going to tell you everything else. All right, give it up for Caleb.
Thank you. Hey, by the way, did you snatch that off my desk and take a photograph of that, or? I did? Wow, okay, all right. All right, so, so it's only that long? That's going to be a problem. Okay, anyway, so, drinking word. Yes, drinking word for this evening. Some of my observing buddies are going to love this one. Cosmosphere. That's the drinking word this evening. Okay. So, I've been looking up at the sky all my life. That is me. That's me dressed as an astronaut for Halloween when I was 5 years old. That's my visit to Roswell, New Mexico when I was 8. That's about the only evidence of extraterrestrial life that I actually found there. And then, of course, there's me with that telescope that I still use to this day. I saved every penny I could back when I was 7 to buy that. But what was really fun growing up in the town I grew up in, Hutchinson, Kansas, was I was actually not too far away. In fact, it was right in the town I lived in, of a wonderful space museum. And actually at that space museum, here in this image, that's a backup Mercury capsule that was on display there at one time that I'm next to, quite appropriately with a Alan Shepard mission badge there on my spacesuit. So this is that space museum. This is the Cosmosphere. And if you ever get the chance to visit, please do. It is a wonderful collection of space artifacts, largest in the world outside of the Smithsonian Institution, largest collection of Russian space artifacts outside of Moscow, Russia. And among the highlights are the Apollo 13 space capsule and the Liberty Bell 7 space capsule right there. That was Gus Grissom's Mercury capsule. It actually sank after his mission. It was recovered by the Cosmosphere and restored back in the late 90s. Yep. So anyway, obviously a lot of food for the budding astronomer / astronaut, as I was growing up. And of course, I would volunteer there for star observing events, and eventually the education director there, when I was old enough, threw an application in my face and said, "You really need to work here." So I went ahead and did that. So I worked at that Space Museum for 10 years, between 2009 2019. I'd volunteered there a couple of years beforehand. So that's me actually doing one of the live science shows there, Dr. Goddard's lab. We explain how rockets work in that show. We use liquid oxygen to soak a giant cotton ball, and we actually make the cotton ball go boom, blows doors off of the place. So it's a real fun time. And then, of course, there's me out there doing a solar observing. So, you know, among many other things I did, that was kind of the highlight of my involvement in space science, you know, kind of during my high school years and when I was fairly young. So I go to Wichita State to work on my master's degree. And when I start there, I actually am a little bit uncertain as to which path I really want to do. I really love the aviation side of things and the aerospace side of things, so as well as, of course, the astronomy and physics side. So I try and double major in aerospace engineering and physics, and it just takes way too much out of you to try and do two majors like that. So I eventually cut it down to the physics. I really love music. I really love jazz music. I play saxophone, so I was also kind of balancing band at this time. So I was actually in the Shocker Sound Band in the years when the Wichita State Shockers were doing really well in basketball. We went to all those NCAA championships. Yeah, that was really fun stuff. And nonetheless, I stayed with the aviation side in a very light way. There was a flying club on campus, and I had always wanted to earn my pilot's license. I'd actually considered going into the military to be a military pilot, but my eyesight kind of got in the way of that one. But nonetheless, so not as stringent, of course, for a civilian pilot's license. So I went ahead and started learning how to fly through this flying club on campus. And that picture is from when I soloed in the airplane there on the way to getting my license. But what's significant about this is that about midway through, actually a little past midway through, it's my junior year, I went ahead and decided to apply for a NASA internship. They had a website at that time called One Stop Shopping Initiative, and all you did was basically put in your application, list a number of different opportunities that you might be interested in doing, and essentially see what you get. And so I went ahead and put in this application. And the week, in fact, it may have actually been the day, but I can't remember exactly for sure. Nonetheless, the week that I actually took my check ride, the week that I earned my pilot's license, is the week that I found out that I actually was going to be an intern at NASA Goddard Space Flight Center that following summer. Yep. So that summer of 2013, I went to NASA Goddard Space Flight Center to intern there, and essentially, I didn't really know what I was doing, really. I thought, you know, this is good. This is completely new. I hadn't been extremely far beyond, you know, a few short jaunts outside of Kansas. And so I go out there to Maryland. Goddard's in the D.C. area, if you don't know. Really fantastic center. Largest concentration of scientists in the world. Yes, that is even compared to CERN over in Europe. It is really a phenomenal space flight center. It is the seat of the NASA Science Division, really. So anything that you can think of that NASA does in terms of their science portfolio, really much of it is done out of Goddard Space Flight Center. And so that's actually me at Goddard Space Flight Center acting like I'm working at the computer there. That was on about the last day that I was there. I had my parents visit, and they had this special kind of, I don't know, social thing or whatever, so that's why I'm in the shirt and tie. I didn't dress like that every day. You didn't have to. But anyway, nonetheless, that's me working at the computer there. And then what was really fascinating about being at Goddard Space Flight Center that summer was that they were actually constructing the James Webb Space Telescope at that time when he was out there. And so they actually had that summer the backup unit. Later, the next summer, I'll get to that in a moment, the flight unit. Actually, I shouldn't call it backup unit. It's a pathfinder, a check unit. They had the check unit in the clean room at that time. Eventually, they had the actual flight unit in the clean room there. So I was able to get to see all of that as it was going on. Just a really amazing thing. And so well, right next to there is kind of a test unit mirror for JWST. But what I was actually there to work on that summer was a star called Eta Carina. My mentor that summer was Dr. Theodore Gall, and he was a very interesting fellow himself. He was actually the co-PI for the Space Telescope Imaging Spectrograph on board the Hubble Space Telescope. Yeah, so really fascinating fellow. And Eta Carina is probably about the strangest star in the sky. Now, if you haven't heard much about it, probably it's because you can't see it throughout most of the United States. It's a very far southerly placed star. It's in the constellation of Carina. So right about here in this nebulosity is where Eta Carina is. And you may just be able to see it in the springtime, very far south, at the very tippy bottom of Texas. But that's about the limit of where you're going to be able to see it. Otherwise, you're going to have to be able to go farther south than that in order to get a good look at it. And this star has a strange story. This star, for a long time, was somewhere around about magnitude 2. Okay, so fairly bright star in the sky, but not bright. You know, you're talking about something in the neighborhood of maybe the stars in the Big Dipper Formation, or even maybe the Belt of Orion. And then suddenly, in the year 1840, it brightens up tremendously to magnitude -1. It becomes the second brightest star in the sky after, in the night sky, I should say, after, of course, the star Sirius. And then it dims down quite a bit, way down here to Mag 7, to the point it's barely visible to the unaided eye. And then it brightens up again in 1890, and then dims down again, and it's been slowly creeping back up ever since the 1930s. So what on earth is going on here? Well, fortunately, with the advent of space telescopes and large ground-based telescopes, we can see Eta Carina in high definition and 3D. Yeah, in 3D, yep. So this is actually an image from the Hubble Space Telescope of Eta Carina, and this is weird. There's a very bright star in the center there, and it's surrounded by this kind of peanut-shaped nebulosity. Now, the peanut-shaped nebulosity is actually the dust ejecta from that 1840 eruption. This can be mapped in such a way to make a 3D model. You can actually go through, take spectra across the nebulosity and find the red-shifted and blue-shifted components, because this is still expanding outward. And you can find, based off that red shift and blue shift component, you can construct a 3D model of the nebulosity. And so I have such 3D model right here. This is actually the Eta Carina, what they call the homunculus nebula. They call it the little man because in old photographs it looks like the Pillsbury Doughboy. But nonetheless, so this is actually that 3D model. And the scientist I was working with, his group actually made this model in the year before I started on the internship. They had just submitted the paper for publication at the time. So at the beginning of the summer, I walk in his office. Myself and my fellow intern, Nick Dorofchuk was his name. So Nick and I walk in his office, and we see a bunch of these models sitting on the table. We start asking about them, and Ted tells us all about what's going on with this. And he says, here, take one of the models, by the way. We have plenty of copies of them. Oh, by the way, you can't talk about this until about a month from now. And the reason why is because they had just basically put the paper through. It was going through peer review and everything. But I think that's the first time in my life I ever had anyone tell me in an official sense, don't talk about something. And as a big fan of the James Bond films, I thought I was real cool. I'm working on secret stuff. But nonetheless, though, it wasn't national security secret, obviously. And once the peer review was finished and the paper was published, I was able to tell everyone back home about this fantastic Eta Carina 3D model I had. And everybody was real impressed with it and everything. But there's more to the story even than just that model of the homunculus nebula. Through these observations over the past 40 years, we figured out that Eta Carina is actually very likely a binary star system, a colliding wind binary system. It's in a highly eccentric orbit, about 0.9 eccentricity. The main member is very likely a luminous blue variable star, an extremely massive blue star, about 100 solar masses plus or minus 20 solar masses. It's a huge, huge star. Actually, the star cluster that this is part of, Trempler 16, is one of these areas where you find a lot of these extremely massive stars like this. And orbiting around that primary is a roughly 40 solar mass companion right there. And this is likely a Wolf-Rayet star, which is a very active blue giant star with extreme stellar winds, probably in excess of 1,000 kilometers per second stellar winds, very, very high stellar winds. And so as this is going around, as the secondary is going around the primary in its highly eccentric orbit, every 5.54 years, the secondary approaches the primary, and these stellar winds, both the high velocity one from Wolf-Rayet and the lower velocity one from the main star, ram into each other, and it causes enhanced X-ray emissions. So every 5.54 years in the X-ray band, and even somewhat in the visible, especially in the ultraviolet, you get this slight brightening, and actually in the X-ray, extreme brightening every 5.54 years. So that's very likely what's going on here in this system. So my job during that summer was to look through old data from the International Ultraviolet Explorer and try and understand what was really happening to the system long term. Is the mass loss rate from the primary star increasing, decreasing? What about the secondary? Is there any evidence that anything about it is changing? So International Ultraviolet Explorer, if you haven't heard about it, it's too bad, because really it is the precursor to Hubble Space Telescope, at least in the operational sense. This mission started in 1978. We actually cooperated with the European Space Agency on this mission, much like we do with Hubble. And the operational characteristics of this, all of this was a template by which we base the Hubble Space Telescope work on. So it was really a groundbreaking mission. It ended in 1996, partly for budgetary reasons, partly because they were starting to run a little lower on the fuel for the propulsion system on the spacecraft. But nonetheless, a very successful mission. This is actually the kind of spectra that it produced. This is what's called an Shell spectrograph, spectrograph right there, and or at least a Shell spectrogram from the spectrograph. And so what you're seeing is actually the far UV spectrum spread out across the phosphor of the imaging system there. So going through the various observations of IUE, you had about 300 observations of Eta Carina that you could use to look at. Limited number, but you go through and you see what you can find. And we did find some interesting things, not enough to produce a paper, but enough to at least get a good academic conference poster out of it. So what we did find was that these spectral lines, the forbidden nitrogen 3, the silicon 3, the iron 3, those spectral lines all increase slightly over time. And that implies that the mass loss rate from the primary star is slowing down. So for whatever reason, the main star, the luminous blue variable star, is stabilizing over time. However, a couple of the spectral, actually a few of the spectral lines associated with iron 2 transitions, they didn't change that much, with the exception we did notice minima, maybe coincidentally, maybe non-coincidentally, near the spectral minima toward the periastron of the 5.54-year cycle. And so what that actually implies is that the secondary star has a Lyman continuum, a hydrogen emission continuum in that Lyman series in the UV that's constant over time. And so that implies that there's a little change in its temperature over time. I should mention that Eta Carina is one of the few astrophysical lasers that we know of. In fact, may actually be the only astrophysical laser that we know of. In this sense, the light emission from the gas surrounding the star causes a lasing effect, where that emission induces other light transitions in the gas, resulting in a laser effect. So a very, very fascinating object. And again, this was enough to get me a poster, along with my co-worker Nick Jarofchuk, at the American Astronomical Society conference in Seattle that winter. I'll tell you about that very terrible plane flight to Seattle some other day. So I actually had a second stint at NASA Goddard Space Flight Center, and unfortunately I don't have a staged photograph of me at a desk on my second one to show you. So this is actually me in Washington, D.C., kind of visiting during that time. That's actually at the Kennedy Center for Performing Arts. If you look out from the balcony of that, you get this really beautiful view of D.C., and that's the Watergate Hotel behind me. Yeah, and yeah, so... Well, I didn't see anyone snooping around with flashlights in the middle of the night looking for anything that time, but you never know. Not that you know of. Anyway, so nonetheless, the next one, though, was a completely different path of research. That next internship, I wound up working on Venus ionosphere studies. And the mentor for this was Dr. Joseph Grabowski. He was actually one of the project scientists for the MAVEN mission at Mars. But earlier than that, he had worked on the ion and electron instruments and magnetospheric instruments aboard Pioneer Venus Orbiter. So Pioneer Venus Orbiter, you actually see it being prepared in the clean room right there. Behind it is the Pioneer Venus multi-probe, which actually sent a few atmospheric probes in the atmosphere. But I'm going to talk about the orbiter for a while. PVO operated between 1978 and 1992. It orbited Venus during this time, basically mostly doing measurements, again, of the ion, electron counts, magnetic field properties. It did have an ultraviolet spectrometer on board. That ultraviolet spectrometer is responsible for the image you see here with the details of the cloud layers of Venus. And I'll tell you what, Venus is a strange case. It is a really, really strange case. It's about the same size as Earth, but it is the only planet in our solar system that rotates clockwise rather than counterclockwise. And its rotation rate is actually longer than its revolution rate around the sun. It takes about 225 days for Venus to revolve around the sun. It takes about 243-ish or so for it to rotate on its axis. On top of this, it does not have an intrinsic magnetic field of its own, unlike the Earth, despite the fact it's actually, structurally at least, or in the sense of its general size and probably its mineralogical composition, not that far off from the Earth. So it's a really strange case. What on earth happened to Venus to make it, well, what it is today, this terrible hellscape with no magnetic field? The truth is, we don't really know. And the go-to explanation in all planetary science seems to be giant impact. Yeah, go-to explanation. But nonetheless, so I'm going to focus on a mystery of the ionosphere. And the ionospheric and magnetospheric observations revealed what are called ionospheric and magnetospheric holes at Venus. And this was also observed by the European Venus Express, which you see in that rendering right there. So these holes are regions in the far side of the planet where the magnetic fields are enhanced and the ion and electron counts are depleted. Now you're probably wondering, what's this about magnetic fields? I thought you said Venus didn't have an intrinsic magnetic field. It doesn't. It has an induced magnetic field, a very mild induced magnetic field. So as a solar wind approaches Venus, it actually interacts with the charged particles in the ionosphere, and it induces a mild magnetic field around the planet. Okay, well, this was observed, fine, but you had these two mystery regions. The direction of those actually varies with the direction of the solar wind and the interplanetary magnetic field, the magnetic field from the sun. And so there's a couple of explanations for what may be causing this. One of the explanations is what's called ionospheric magnetic congestion, where basically you have the ion flow from the day side interacting with the cooler ion flow in the ion tail on the night side. You get these two regions of charged particles buffeting against each other, and that generates the magnetic field there. Yeah. And then you also have the idea, of course, there being a draping of the sun's magnetic field around a possible core, IMF draping. So which one's the case? Well, I wish I could say I found out what the case was. I didn't. But nonetheless, though, I did do a series of investigations of the holes, very limited because PVO only made a few really good observations of these holes where you had calm solar wind conditions, stable solar magnetic field. And so we found that, of course, you had a pressure balance at the hole boundaries, and we could measure the electric currents at the hole boundaries. But this measurement of the electric current actually implied a horizontal flow of these of the current generating element. So strange stuff there. Again, not enough to really get a paper or even a poster out of it, but interesting investigations nonetheless. So after I graduated from Wichita State University with my bachelor's degree, I applied to graduate school. I went to KU, University of Kansas, for a year, and that didn't work out. Everything that could have went wrong there did go wrong. And I wound up having to go back to the University of Kansas, go back to Wichita State University for my master's degree. And I'm glad it happened that way, because I wound up working on some really fascinating stuff there at Wichita State University. So there's me, there's my master's degree advisor, Nicholas Salome. And we actually worked with some folks at NASA Marshall Space Flight Center in Alabama. So that's me at MSFC next to the old Redstone testing tower out there. Really an amazing thing to see if you get the chance to go there and take a tour of the place. A lot of the early history of space flight is based there. So this project that I was on was essentially focused on solar neutrinos. So in the core of the sun, you have fusion of hydrogen. That hydrogen fusion generates energy, but also generates these weakly interacting particles called neutrinos. In your thumbnail right now, there's about 60 billion neutrinos a second crossing through that thumbnail, okay? So pretty high flux, but the problem is they're weakly interacting. So normally we have to use these really big particle detectors on the ground in order to detect these neutrinos. But if you get closer to the sun, if you get closer to the sun, the flux of the neutrinos goes up over 10,000 times, several orders of magnitude. So maybe you can take this and put in something the size of Parker Solar Probe if you can, of course, make the systems necessary compact enough. But the problem is you're in a very intense radiation environment. So you have to be able to filter out the background radiation events. And so my advisor kind of came up with this idea, how about a veto array system for the detector, where you have a detection element around the main detector element, and that detection element detects any of your background radiation events. And then the main detector element is a scintillator. In other words, it phosphoresces when you have a charged particle go through it. It's a scintillator that's doped with gallium. And the neutrinos weakly interact with the gallium, and that decays into germanium. That actually causes an inverse beta decay to germanium, and it produces an electron and some X-rays in the process. So that you can detect as double pulses in the scintillator volume. So I did these simulations on this, and I found that you could actually detect somewhere in the neighborhood of about 30 to 40 detections per month if you were at 3 solar radii, so about as close as you could possibly get with modern technology, and 90% true-false rate at 3 solar radii. So it's not implausible to do this, and the group at WSU is actually still working on this as we speak. And so then I come down here to San Antonio. I reapply for Ph.D. programs again, get in here, and University of Alabama, Huntsville. Here, everything has been wonderful ever since then. So that's my advisor right now, who's Will Rout and I working in the lab. That's me star observing, and yes, the stars at night are big and bright here in the heart of Texas. And so that's me next to the 30-inch telescope there. So again, just really fun time down here. Part of what I've done is, of course, focused on the moon. Part of what I've done is focused on Sharon at the moon. It has to do with the Lunar Reconnaissance Orbiter LAMP instrument at Sharon. Observations by New Horizons, of course, that red region towards Sharon's North Pole. Laboratory investigations of the moon I've done are using this instrumentation. Apollo 11, 16, 17 soil sample. Highly space weathered, low space weathering. So an opportunity to compare different chemical compositions and weathering properties. And of course, we found that the more weathered soil, which has these nanophase iron inclusions, is darker and more backward scattering compared to the less weathered soil, which is more forward scattering and a little bit brighter. And that could be for a variety of reasons as well. That's brighter, mainly the glass content of the soil. Now at Sharon, you have this process where the background interplanetary medium Lyman alpha processes the methane that's secreting from Pluto's exosphere onto Sharon there. This process very likely generates mostly ethane, and ethane may be colorless, so these are the peaks that you find in spectra at the low phi case, where you have mostly Lyman alpha radiations compared to methane flux. And then with the higher methane flux, you get, again, mostly ethane. It may be colorless, but I've actually done experiments where you observe this ethane after you've warmed it up for a bit, and the ethane starts reddening on its own at the higher temperature range. Now, this may not be the whole explanation for why the red region at Sharon's Mordor Macula region is what it is, but it may be part of the story. So, just to summarize, I've had a ball of a time. It's really been a great run, and I can't wait to see what's next. I've made some great friends along the way. You can see all of them in these photographs here. I met some fascinating people. That's me talking to Harrison Schmitt, the Apollo 17 astronaut who walked on the moon, Apollo 17. Got some great astro images along the way, annular solar eclipse, comet last year, even the aurora down here of all things. So that is my adventures in astronomy. Thank you.
Thank you, Dr. Gimar. I remember that top left. Well, I remember that bottom center right, but the top left at LPSC. I remember you saying, "That's Harrison Schmitt. I'm gonna go talk to him," and you just walked right up to the stage and you go talk to him.
It wasn't quite like that. I was actually blocked in the same block of talks that he was in. So yeah.
So what was your normal attire at Goddard?
Normal attire at Goddard is about what I'm wearing right now: polo shirt and khaki pants. Yep.
Are pulsars lasers, or is that a different kind of
That's
physics?
That's a different physics, different phenomenon. The pulsars are due to magnetic acceleration of the of ionized species and the radiation emitted from that, but it's not a lasing process. So
how they track the star's brightness in the mid-1800s for Eta Carina?
Very.
How can they compare that now?
Very good question. So in the mid-1800s, it would have been done visually. A trained observer can actually give you pretty decent measurements of the comparative magnitude of a star. There's a whole group today called the Association of Variable Star Observers, American Association of Variable Star Observers. And a lot of these members to this day will do visual observations of variable stars and record their observations. Of course, the more observations you get, you can average those, put error bars on them. The more observations, the smaller the error bars are, and you can do it that way. Now, pre-modern astronomy era, pre-1700s, really, that's a little harder to say. Yeah. In the case of the pre-1700s observations, you kind of just have to go by what little is around in the written record of this star looks like it belongs here, this star looks similar to this star here kind of thing. Yeah.
And then to the person who texted me about Guy Fawkes Day, yes, we remember the 5th of November. But for that person, and you are the one to ask, what are your dark sky recommendations?
Oh, good question.
Especially for meteor showers coming up.
For meteor showers coming up, yes. So dark sky recommendations here in the nearby area. Obviously, again, the group that I'm part of, we go out to South Yana River State Park an awful lot.
Which is about north.
About northwestish, yeah. So
about
really,
2 hours.
Yeah, really anywhere kind of west of here is pretty decent. So yeah, if you go about 2 hours from this spot northwest, you hit South Yana River State Park near Junction. Basically, just keep going up I-10. You'll find different places along I-10 farther up that way that aren't too bad. If you go immediately west of here, Garner State Park is actually very, very nice. I've been out that direction a few times, and it's really very, very good. So, yeah, but that's something I always say. The best telescope is a dark sky. Actually, I have these rules of astronomy, that the 10 commandments of astronomy is what I call them because there are 10 of them. Number 1, find a dark sky. Number 2, find a dark sky. Yes, the first 2 rules are the same. Third rule, if the guy taps out, then no.
If you want to get real crazy with dark skies, Big Ben.
Oh, yeah.
Some of the darkest guys in the country around here.
Yeah.
But let's give our speaker another round of applause.
Oh, thank you. Yep.
Thank you. Thank you so much, Caleb.
Caleb is around if you have any extra questions.
Yes. Am I on? Okay. That was great. We couldn't AOT wouldn't be the same without Caleb. So we're thankful for all of his contributions to our event. If you have to leave, thank you for coming, and we'll see you at our December event, which will be on December 3rd. December 3rd. I know that because December 1st is Monday, because I just booked my flight today. So we'll see you on December 3rd. If you can stay for trivia, you know the thing. We'll pass out sheets, writing utensils, groups of 4, please, no more than 4, and prepare yourselves.
We will start momentarily. I have to use the facilities.
Okay. Let's get started.
Wait, we have to explain again.
That's right. All right, as usual, everybody's in groups of 4 and no cell phones. But tonight there's an extra rule, and also make sure you just write the letter. But this is Who Wants to Be a Millionaire trivia. So the questions, not only will they get progressively harder, but much like the show, once you get one wrong, you're out.
You're done. And
Now-
you won't know until we grade, of course.
Yeah. You'll be able to play all of them, and perhaps you getting more right will settle tiebreakers, for example.
Yeah.
But you gotta stick with it. You gotta keep going. You've got to be a planetary millionaire, and that's a real thing from the planetary data system. Remember at the conferences?
Yeah.
Well, all right. Question 1.
Oh.
Yes. Actually, yes, I forgot. These are actually real questions from the show, by the way. So these are not fake. Sam did not make these up on his own. So thank goodness. Am I right? All right, here we go.
Question 1 for $1,000. Actually, $2,000. Which of these states in the USA is most likely to see the aurora borealis? Is it A, Alaska, B, Oklahoma, C, North Carolina, or D, good old-fashioned Texas? Hey, this is the $1,000 question. We're starting them off.
Well, 2,000, but yeah.
Remember,
Remember, so $2,000 is right after the first. Is question 6.
this is 1990 money.
Yeah, and this is question 6 on the original show.
Oh, this is more. Wait, what does it start at?
100, 200,
No, I know
300,
to count
500,
6.
1,000.
1, 2, 3, 4, 5, 1,000.
1,000, then milestone, and then you come back and start. I wish we had the music. Wait,
I know, we need the
actually.
lights. No phone a friend. No lifelines. No, there's no lifelines. You can only phone a friend if you think you've won the $1 million. And the $1 million is not quite $1 million. A nice lithograph. Oh, Michael's got it. Maybe.
I don't know.
He's got Regis in his ear.
Oh, yeah. I'm doing a séance.
No, the. This is.
All right. Well, we'll move on. All right. So the next one is 4,000, but this was actually a $16,000 question. In astronomy, which of these terms means a giant cloud of gas and dust in space? Is it A, pulsar, B, quasar, C, nebula, or D, supernova? Here's a thing.
Gotta do the whole production of like talking it out. Like, well, I know this answer. There we go.
Oh wait, no, that's you got it wrong. No. There we go.
Yeah, we need a blank final answer.
Supposed to switch.
And is that answer correct? We'll find out after the break. Could you imagine if we had sponsors? If we had sponsor breaks?
Wait.
Yeah.
Okay. All right.
Hey, not everyone knows the answer. Not everyone is inclined as us. Question 3 for 16,000. Subatomic particles are accelerated around the Large Hadron Collider at close to the speed of light by what mechanism? Is it A, superconductive magnets, B, nuclear propulsion, C, rocket turbine engines, or D, compressed liquids? I know, I wasn't trying to think of, I can't do, I don't have that tenor. I don't have that timbre. I just imagine like Regis sitting across like, now Michael, you've worked with rockets. You have history. Is it?
Music copyrighted?
Someone's got to submit a complaint. Also, do we have like, I don't know if we're doing, yeah, we're not doing AdSense, I don't think, so. If we're not making money on it, you can do whatever you want.
Next question. Wait, okay.
We'll come back if necessary to repeat questions. There we go.
We're getting harder. All right. For 64,000, actually 125,000, which planet was discovered by William Herschel in 1791? Was it A, Uranus, B, Neptune, C, Saturn, or D, Venus?
Sam, are these also the answer choices? Everything is direct from the show, which is kind of crazy. All right. Question 5 for 125,000. Which city famously turned on its lights as John Glenn passed overhead during his 1962 space orbit? A, Osaka, Japan. B, Perth, Australia. C, Vancouver, Canada. Or D, Toulouse, France. That was a good one.
Wait, I... Toulouse-Lautrec. Wait, hold on. You all remember the show, you have lifelines. So we're gonna use 50-50. So computer, please take away 2 of the wrong answers, leaving behind the correct and 1 wrong answer.
This is fun. This is fun.
I love this.
You're just like,
This video has everything the thing.
Yeah.
Just click on the timestamp.
yeah, that's nice. All right. 50-50. Question 6.
Who was the first man to travel into space twice? Was it A, Vladimir Titov, B, Michael Collins, C, Gus Grissom, or D, Yuri Gagarin?
Regis, that's my final answer.
What are you doing?
Are there any more? There's no more lifelines? Nope. Call a friend?
Phone a friend.
Your one opportunity to. Yeah. All right. Do you want to move on to the bonus or go back? Yeah. All right. Now, this is question 7. It will go in the bonus section. It's the $1 million question. And the question is.
Wait. Did you say go back?
For $1 million, what golf club did astronaut Alan Shepard use to make his famous golf shot on the moon? Is it A, a 9-iron, B, a sand wedge, C, a 6-iron, or D, a 7-iron? Huh? Oh, this goes in the bonus section. Just the letter. make much sense. Okay, does anybody need a question repeated? Hold your fingers up if you need a question repeated. Everyone's got their answers locked in? All right. Regis, that's my final answer. When you're done, if you could please bring up your answer sheet, and if we gave you a pen, please give it back. We would like them back. We are poor. Thank you.
Last one is the one that I'm not sure of.
Trying to find good waiting music.
Do we have everybody's answer sheet? I think we do. That's everybody? All right. Hold, please.
What was 5?
No, they got that right.
Oh.
They got that right.
No, it's C. You're looking at the wrong.
Oh.
This is the key.
Oh, they all got it wrong. Should we, I mean, we have enough of these. We can all, let them do a grab bag choose if we want.
Yeah, we could.
I really don't mind that because we have a bunch of them.
Yeah.
You want to do that?
Yeah.
All right. I'll get the bag. they just pick whatever they want?
Well, including these.
Yeah. First, second, and then a three-way tie for third. All right, that was pretty successful. What is this? It's very successful. Yeah, it worked very well.
All right. We have answers for you. Question 1. About the aurora, which state is
Oh yeah,
like
which state? Which state for the aurora borealis? A, Alaska. The most northern state. That one's pretty straightforward. I think every single team lasted until round 3. So round of applause for everyone who doing trivia. That was pretty good. And the question 2.
in which giant giant cloud of gas and dust is a nebula? Woo!
Go state. He's pulling up he's queuing it up. God damn it, Regis.
Just keep going.
All right, question 3. What was question 3 about? Oh, LHC, superconductive magnets. All right, those were pretty standard, pretty easy. And then this is where it got dicey.
There we go.
Question 4 was about who discovered
Who
what?
discovered? Or no. William Herschel in 1791 got Uranus.
And this one's pretty cool
This
because
one.
someone did math and was like, hey, there should be a planet exactly at this point. And William Herschel said, bet. And he found it.
Bet.
Oh, William Herschel said there should be a planet here? That I do not recall.
It was Neptune that was mathematically determined.
I thought Uranus. Who knows?
All right. Question 5.
Question 5 was which city, Perth, between Perth and Osaka. That's what I was thinking. I was like, how friendly were we with Japan in the 60s?
All right. Now, this
Cordial.
This question, one team, besides the hosts, of course,
Yeah.
only one team got it right, and the answer was Gus Grissom. I am. Well, they got it all wrong. That was a gut feeling, and you know
Yeah.
what? That's what they always say on the show. They say, "Go
Yeah.
with your gut.
Go with your gut.
Don't change your answer." All right. Now, I'm not going to say nobody got the million. People got the million, but nobody
Went all the way.
went all the way. Nobody got perfect. So unfortunately tonight,
In the spirit of the game, no one got a million.
exactly. But what was the million question? What was the golf club? Aaron?
A 6-iron. Now, Caleb, what Apollo mission was this? What number? Oh, 14. Okay. Because I thought he would have took the iron that was corresponded with the mission number.
No, it's too high a number.
Yeah.
No, really, and again, I didn't get this right. There's probably a weight consideration.
Well, the 6, 7, and 9 are pretty.
They're pretty similar.
Yeah.
I don't know.
Yeah. A couple people got
Yes, a
got
few.
it right,
Yeah.
but yeah.
This was actually a
okay.
tiebreaker. We
No,
used
no.
it as a tiebreaker.
We were talking about
so.
like in the 60s, the sandwich wasn't quite the sandwich as we know it today. And in the 60s, I don't know how much Surveyor convinced them of the regolith properties that would have said, "Oh, we should take a sandwich." So like that's what I was thinking because I golf, but like yeah. So that was my thought process.
All right. We have winners to announce. In third place, with a three-way tie. So y'all are going to get to go in the grab bag of 3D printed space objects. We have Quattro Formaggio, Wolf Rayet Stars Rule, and the RT Virgins. Come on up. Send a representative and get your thing. There's also these two. Yeah.
You are allowed to go through the bag. Do not take an entire bag, but you are allowed to go through the bag.
Well, I have so many of these.
There's Mimas.
Do we have any fun Edicarine?
Yeah.
Go with
God.
Go with.
All right. In second place, and they'll win this beautiful STSCI poster, Star Master. Woo! And in first place, with our we'll call them our millionaire of the night, Dr. Planet. Hey. Wait, I have, this is my favorite sound. Well, we're out of time, everybody. Thank you all truly for joining us tonight. We had a great time. We hope you did too. We'll see you all next on December 3rd, where we will have, do we have Cindy?
We do.
Yes. UTSA grad student Cindy Lou is confirmed, as well as, do we have a second one? Or
Nope.
No. Keep poking Dr. Preston. Maybe he'll be our second speaker, but we'll find out. Have a good night, everybody. Thank you, and thank you to Blue Star. They're, as always, fabulous in their service.
Au revoir.